Hi, my name's Evan Williams. It says that somewhere, right? I put Trending Computer Festival. Today's the 16th of March. I'm here to speak with you about embedded development using C++, if that's okay. Um, good. And let me turn the page here. I'm a little nervous, but I've spoken to group classes a lot. I taught at Fordham University. What happened? Here they are. That's the agenda. I'll go back to the agenda in a minute after I introduce myself, okay? I wish this little glyph would go away. Let me see if I can move it. Ah, it's impossible, but I'm glad I'm here. And okay, so I have three college degrees, and I've spoken at TCF since 2016 or 15, I forget which. And I've been focused on in my own company, which is Evan Williams Consulting, and the little pens and USB hubs which you can take on your way out are right here. Um, I've been focused on small board computers. It's kind of something I really enjoy. And let's see here. I've built web. I've I've built. Hi, George. Come on in.
Just gonna pass that to you later.
Thank you. I've I've built websites and worked on three-tier applications and started out with CPM when I came to TCF for the first time in high school, I guess. And my dad bought a CPM computer and we brought it home, and that was an 8-bit computer. Um, and then I've had a career that's been pretty good. Right now, I'm trying again, and I'm a little nervous today, but I'm feeling all right. Um, I start after I graduated with one of my degrees. I was employed as a technical writer in Edison, New Jersey, at a company that had a lot of different computers, and they had to port Tuxedo, which is part of NetBeans, to all the different computers. Then I did database development and finance and web development, and now I'm on my embedded development phase of things. And I also taught for one semester at Fordham University. That was good. It was data and uh, information. Okay. Oh, here's a funny joke. I like jokes. I like, as long as they're uh, not offensive. But this one, I'm working on this. These are my units of measure: the bit, the wire, and data. There's otherwise you would go for the meter, the pound. I try. Here's our agenda for today, if it's okay. We have a small group, so please interrupt me at any time to ask questions, and I'll try to answer them. I'll try to gauge what I'm saying to the group. And the fact is, we will be learning together. I don't know it all. No one knows it all. No one has all the tools, but I've had some experience that's been helpful. So what I want to do in the 15 minutes or so, or 40 minutes, is give an overview of programming languages, talk about what object-oriented development is and why it's important to embedded computing, uh, ask what C++ is, and then I have two examples using C++, and then on Arduino, which I go into detail with a code review on each one. So I've been prepared in that way. The thing I'm not good at is Raspberry Pi, ESP32, and many of the other boards. I've gone as far as I could with Arduino, and I didn't do as much research on Raspberry Pi. But I have all the Linux background, so it's like everyone brings what they have to the table, and when you're with others, people can fill in where you lack knowledge. So that's the concept here, to be collegial. And let's go right through it then. Um, Types of programming languages. Okay, does everyone know what a computer is? And what's the difference between a computer and a calculator? That's what I like to ask. Yeah.
these days the line between them is getting blurred.
It is.
You can program computers to want to do procedural things. Calculator, they're getting better.
Even on the smallest calculator, it says 1 plus 2. I can't say print unless I do 0.7734 and turn it upside down, at which point it says hello. So I did that affair. But seriously, even a programmable calculator is going to have a fixed number of things it can do, whereas a computer, for all it's got, can be reprogrammed to do lots of different things. And then, like you say, a programmable calculator is able to go a little further. And then maybe if it has one window, and of course, I'm sort of, well, the longer you work, the more data you get, it's just going to return one value or one computation. So that's kind of a good answer. And then the next question is, to get us up to speed, does everyone know how a computer operates? Have some idea about the internal workings of a computer? I did not prepare slides on this, but I wanted to start by giving you an overview of programming languages before we talk about object-oriented programming languages. So let's talk about what assembly or machine language is. This is actually what it looks like. This is pretty close. This is assembly language, and it's very, very basic. I have my markers here from when I taught Fordham. It was a pretty good class. They were all undergraduates. They were really motivated. And we taught Python. I could write on this board here. Would this be good? Yeah, so in a, there's two kinds of processors. There's reduced instruction set computers and complex instruction set computers. But essentially, every processor is like a calculator in that it has an accumulator, and we'll call this accumulator A. And if there's a program, here's a program, it's going to go through the instructions one at a time. And if the instruction, and this is on the actual wires of the computer, which is amazing. This might be RAM memory, random access memory. There might be a number that says D402. Oh, load the number 1 into accumulator A, and it actually takes this 2, which is in the memory, and puts it in accumulator A. Then I say add. The next instruction in memory says add 04. So then it goes 04. Remember, this is, and then the final one says, and when it says add, well, it says it does it immediately, and the answer is 06. And then the final instruction here in our little program is store in memory location 444. Well, that might be down here somewhere. And remember, all these machines are a little bit different. Whenever you start up at this level of programming, you've got to try to understand what the machine is doing. The number 6, then gets put back in memory, and the final instruction is do nothing or end. And the whole process stops. But remember, this is happening in binary. Do you all know what binary is? Yes? No? Okay. Binary is very simple. You're counting in base 2. Okay? Let me count for you. Okay? No, I've been thinking about this all day, and this is what I do. This is my life. So I don't have an eraser. Here it is. The count to 10. How about to 4? It's 0, 1, then what? There's only 2 states in binary, 0 and 1. It has to, you add them up, oh, and then you're adding a 1. It has to kick it over, and it's 1, 0, 1, 1, and then 4. If I do 1 plus 1, 1, 1 and 1 does not equal 2. It equals 1, carry, and 0. 1 and 1 again is 1, 0, 0. All this stuff is tricky. It's stuff you have to learn. But when you get up to speed, then you understand what assembler is. And I'm not here to lecture. I'm not here to lecture you. We're here to talk about object-oriented programming. So let me move on. And I'm just getting the the whole thing ready to for that purpose. Why am I talking about object-oriented programming today? So you can build more complex systems. So you can build systems that do something that even deal with AI or more sophisticated um, needs than you can handle. Programming a whole computer by writing out the numbers so that the memory space is going to be programmed properly. It takes forever and doesn't make a lot of sense. However, let's start with procedural programming, all right? And I think you mentioned this, the idea of procedural programming just a minute ago. We can't write out all these numbers all the time to program computers, and we really can't write down the. I'll take this one. This board's so good right here. I think I wrote on the wrong board. Well, I may have made a mistake here, right? I'll just stick to this board right now. We can't really write out all these assembly codes to make an Arduino or something work. So what we do with most programming is we can program in different languages. The languages help us. The language I started out was BASIC, and that's like basic input. I forget what it stands for. I haven't looked that up lately. And you used to say 10 print hello, and 20 go to 10. We used to have fun with that. What does that program do? It loops. It just prints hello over and over again. It's a procedural program. It starts at the beginning and it runs through to the end. If you say we printed enough or if print 10 times, you've got to program all that to do that. That's procedural programming. It can have subroutines. You can use libraries. You can use data structures as needed. Higher level functions called lower level functions. There's a write once, run multiple philosophy. Because remember, above all, we're lazy. We want to write the program and be done with it. Here's object-oriented development. The creation of programming structures called classes that reflect the operation of a real-world object represented by, controlled by, or needed by a program. So this is really where we want to get to, where we're not using structures anymore, we're using classes. And I'm going to talk about how to program, do object-oriented development, something I learned to do. And maybe it'll help you with your projects. They don't have to be embedded projects. They can be regular computer programming projects. Okay. It's really highlighted by the fact that object-oriented programming is not procedural programming. The concept of cookie cutters is a good one. If you have enough dough, you can keep stamping out these cookies if you have the form made already, but you have to have the form made. That's very similar to how classes work in C++ and other object-oriented programs. Okay, so data structures called objects are created as needed. The objects have methods instead of functions or procedures. Objects obtain an identity when they're instantiated. They know what they are and what they can't do. And then once the object is instantiated on the heap, the operating system or program can tell it to do all the things that can use these objects. So let me explain to you. I had a class, as I said I taught one semester, and one student wanted to write a tic-tac-toe program. Now imagine you only had a console like the old computers used to have. How would you write tic-tac-toe? And C, you start with a main. It always starts there. And it might say, ask for input. So, and then display result, compute result. These are all very helpful functions that we're writing. Compute result. Oh, we need a loop. So I got to say, how do I write a for loop in C? I don't know. I'm kind of making it up right now. I equals 1 to I is less than I is less than 1 or something like that. I plus plus. Do people know this sort of thing? Or how you have to tell me? Do people know C? Yes. Okay, good. Do all of you know? Do you know C? And so you've seen this sort of thing before. And when it's done, when we run the program, it's going to say, okay, tell me your entry. And you're going to put in like A1, and it's going to display the tic-tac-toe board, and then repeat the process. Okay. In object-oriented programming, what we're going to do is actually create objects. So there's going to be a board object, a player object, and the entire system comes together a little bit differently because it's going to there's going to be a bunch of objects, and then the objects then run. So like class game would use a board, and we might say board setup. There's also a class board. And then it then has the definition of how to print out the tic-tac-toe board. Okay? Or set it up or clear the variables. And I'm not going to go into depth about this today. I'm trying to do a high level talk for you and sort of lead up to where I am with some of these developments. Here's 4 useful terms you should know for object-oriented programming, and they're instantiation, inheritance, encapsulation, and polymorphism. Okay? Okay, so now when you write out a program, remember this is actually text that goes into a word editor and ends up in your computer. When it's compiled and the program is run, if there's a board setup, the computer has to instantiate this class. So it reads the definitions of the class board and creates the memory structures of the object. That's instantiation. Object-oriented programming is also very helpful because there's inheritance. What if you don't want a tic-tac-toe game, but you want to play hangman? Okay, that's a fun game that people like to play, right? So what you can do is just say extend game and class hangman inherits. And I don't have all the syntax exactly right up here, game. And now instead of playing just a tic-tac-toe game or whatever it was, we're now playing hangman, but we're using the same objects and the same development as we did before. Okay, so let me keep going. Oh, 2 more. Encapsulation. This is a very important concept in object-oriented programming. Encapsulation means even though I'm playing the game object doesn't know anything about what's on the board. All it knows is the public functions it's allowed to use, like make move, okay, or print board, or clear board. Every other feature of the board and the program in object-oriented programming is encapsulated within the class. And it's all done in the text editor in C++. And then polymorphism is another. I wish I had had a slide for this one. We did inheritance here, which class hangman inherits the game that we use for tic-tac-toe. But you say you were discussing vehicles instead of games. Then you could say something like electric car. So we want to have an electric car object, and we have a we already have an electric unit. We want a class that inherits from an electric object and a car object, okay? So that's just in inheriting both the attributes of both of these, we get electric car. And of course, you're asking how this would happen in an actual programming environment, where we took two broad concepts and created through polymorphism an object that's already understands how to behave like an electric car, maybe for the dashboard or something, because it inherited both of these things. So through polymorphism, okay? I'm trying to keep it at a high level, but of course, this is what programmers do, is try to stay at a high level and get things to work the way they want them to. So, and then I did some research and I found out there's something called declarative programming. This is new to me, but I just took an Arduino workshop and it turns out that declarative programming is actually kind of important for Arduino. And there's a program called Ladder that lets you tell the computer what you want, and it generates the program. So you don't have to do so much programming. And that's what ladder logic looks like. And as soon as I get a chance, I'm going to try to do some ladder logic. It's not unlike Scratch, if you know the MIT program Scratch. So we're doing good. Okay, so we covered I've given you an overview of programming languages with an emphasis on object-oriented programming languages. Here's some ways to characterize programming languages that might be helpful. What is the concept of higher or lower level? Procedural programming can be pretty close to the machine code. Like C programming language, even though you type phrases like print tic-tac-toe board and it does it, it's really going very low level. It's getting the glyph for each part of the board and putting it on your output device. When you go up a level, you're using objects to say, give me the screen real estate as you understand the computer, and I'll render my game on your system, whatever it is. And it could be one of these screens, or it could be an LCD display board, or it could be any number of things. And then fourth generation languages and AI is where you're telling the system, just make a game for me. Can this happen? That's what I'm wondering, okay? I'm already out of a job, so you don't have to worry about whether it's going to put me out of a job or not, okay? I'm clear. Okay, but then compiled or interpreted. This is also a very important concept, typed or untyped, and I've written these out for us. So, I use the example of setting an alarm clock, an actual physical alarm clock. That's pretty low level. But with the Amazon Echo, you could probably say set the alarm for 8 a.m. or 5:30, and it would do it. That uses quite a bit of functionality. A smart alarm clock might be something else again. I just mentioned this one. I always go back to Alan Turing for limits of computation. Using the notion of computing defined by Turing, and this was a tape in which the characters went back and forth, and you could just the computer could write onto the tape, and then it would pass it back. He said he proved that certain statements, when entered as an input, could not be answered by any Turing machine, and this became very important. Computer programmers have gone back and forth for some time as to whether programs are solvable. So I was so curious. I thought maybe there is something I could get involved with AI for programming. And I found out that there are systems out there that will look at every program I've ever written or whatever's on my computer and like rewrite that for me. But there are limits, and this is a place to start. Typed versus untyped languages. So we don't want to write out machine code in assembly language unless we have to. And this is some reason why we have to go to the bit level and tell every bit what to do with. And for embedded processors, you often do have to do that. But when we start using a higher level language, then this is a possible concept as whether we have to know are we talking about a character such as A or the number hex 441, which is A also, and do we have to specify if it's typed or untyped? Many programming languages expect you to say it's an int or it's a character, but other programming languages will let you just kind of go free form, and then it'll decide what it is when you ask it to add a plus 2, and what do you get? Okay. Uh, yeah, you get a with a 2 written on top of it. Okay, I'll work on these slides, all right? This is the first time I've done this sort of talk. Are we doing okay? Good. Compiled versus interpreted. This is very important. In a compiled program, we're taking a text file. We're writing out the whole thing, whether we do it in C or C++. And we have main, and after main it says, I'm doing a loop, and there's sub functions. And then in the class system, we have a top class. This all gets compiled and turned into an object code, and that object code is run on the computer. Whereas interpreted is different. Interpreting is more like Python than C. And of course, Python isn't than C++, excuse me. Python is an object-oriented program. But you get a prompt from the operating system, and you say, I tell my Python program or the shell compute 1 plus 2, and it returns a 3. But I equally could well enter in a whole program, and it would give me the result, or it would say, okay, program stored, run the program. There's an interactive shell, and that's an important distinction, and I don't want to go too far with it all right now, because we're doing good, and I want to pass the examples around. I like jokes, and one of them was go forth, but go and forth are both languages. I had a boss who used to say things like that. He'd say, fly be free. He said, his first boss told him everyone needed, that was when I was a technical writer, everyone needs a hook to hang their hat on. So, but going forth, I was thinking go forth, it wasn't that funny, but these jokes aren't so funny because there was an old programming language called Forth, and that's what the code looks like. By the way, these two slides are from rosettacode.org. There's a plethora of languages out there, and you need to go out and look for the ones you need. You might not need Forth anymore because this was like one step up above assembly language. It wasn't even as far up as C. It's very low level, but it was very powerful because you could write snippets, and because there were labels like for printer emit, console emit, you could use them over again and not get stuck in what code did I write? Go is something I want to learn. This is very important on Google. But if I have a need, I need to learn these languages and get a job. It's hard to do all that and have experience too. Okay. But anyway, that was from Rosetta Code. What is object-oriented development? I've given you an insight into that, I think, a little bit. But what are examples of objects? When we're using Arduinos and we're lighting lights, LED diodes, and we have push button switches, we might have a temperature sensor we want to use with Raspberry Pi. Those are objects. In a computer program, we could have a light emitting diode object, and that's what I have for you in the code example. Do objects have to be real world things? Well, I said no, because dreams are not objects, but if I have a class dream, who knows what it's going to do? But I guess the psych people know that, so I'm safe. Um, but no, seriously, finance might have a number of objects, whole sets of objects for their internal operations. They do have to represent real world things, let's face it. But it's not like, oh, here's a light. That's definitely an object. No, I'm talking about um, statistical accounts and everything Python can do with data science can be represented as objects. So, but I was thinking more practically for this talk. I'll have to work on the slides. Okay, it's my first try with this lecture. Here's classes in Python. I just sort of wrote some classes on the board in rough draft in C++. Python's much easier to use than C++. Yeah, this talks about C++. Um, Python encapsulates, they are using that word again, all the legwork you have to do to use C++, because to write a C++ program is a lot of work. In Python, you just say class my class, and you've got a class. In Python, white space is very important. And I know I'm on track if I'm talking about Python now. and everything underneath that class moniker, my class, is part of the my class. Um, it's a good way to start with classes. But for this to happen, there's a lot that goes on. And Python is interpreted. If you were to write the equivalent program to say hello world in C++, you would see a lot more code that when compiled turns into every little bit that needs to run. And we haven't figured out how much this weighs here yet. In other words, how fast is this going to run? But that's not what we're just here to kind of have an overview and not get too concerned about the details. Here we define the class in Python. Here we say the variable x equals my class. Using the class constructor, we can create an instance of this class. This is a lot easier than C++. And then x period f parens from the definition of f prints hello world. I should have named that better. But I guess I was doing the best I could. And how is a class different from a function? If we have a definition that says print hello world, oh, there I fixed it. I said definition say hello as part of the hello class. I've got to instantiate the hello class and tell a hello object to say hello. And print in this program here, there's a function called print hello world, and then Python starts up, and the moment you call it, it prints it. There's a distinction there. Okay, you can see that, right? And maybe you would need to try it out. And Python's easy for you to try out on just about any computer you have. That's how I would recommend you get started if you're new to object-oriented development and you find this interesting. And then we can build different programs. Why C++ then? We could have chosen Python, Node.js, even object-oriented PHP. And Python, as I mentioned to you, is right out of the box. It's all ready to go. It's interpreted. It's easy. Well, I'll give you a reason. On Arduino, there is MicroPython, but I can't very easily program the details of Arduino with Python. Although there is MicroPython and CircuitPython, you don't have to use C++. You have to choose one or another, though. Node.js, that's server-side JavaScript. Do people here know JavaScript? Okay, so I'm talking to a good audience. I have it at the right level. That's important for me to know. You know what I mean? Node.js is very good. Node.js will do a lot. It's really exciting for me to see JavaScript being used. JavaScript is an object-oriented language, and it was intended as an object-oriented language, but it didn't get when the Netscape war occurred with Mozilla and Internet Explorer, JavaScript lost a lot of favor. But Node.js is used on the server side, And there's features in JavaScript that aren't in C++ that are pretty useful, but I've bored you enough. And then there's PHP. PHP is the quintessential web programming language. If you're going to program the web, you'd better be using PHP, in my humble opinion. It's object-oriented now, too. Would it be good for embedded development? Maybe, if you have a development that requires a bunch of websites. And then C++. C++ is not the only object-oriented language. I don't know about it being the first, but it extends C in a way that is still machine-friendly. It's able to support objects, and as a result of its integration with C, it's nearly compatible with the machine code. Okay? Okay. I do kind of have a funny story for you if you want to hear it. A lot of these boards we're using, we're programming in C++, and we'll talk about it with Arduino. I've done more with Arduino than with Raspberry Pi. You can program a Raspberry Pi using C++, but you might be better off with Python for that. But one time, my friend who I went to school with, I started out at Princeton. He went to Princeton. He worked for Apple Corporation. He said, "Does anyone have any books that can help me learn C++? I'm building a big system. And at the end of the day, I need the budget to be a budget object that knows enough to get the reports out," or whatever it was he was doing. I said, "Yeah, Monty, I have a book. And it's using C++ on Unix." Do you know everything in the book was a system call for C? Because C++ is an extension that lets you build objects of your own. It's not meant for going internally to flip bits in the code. And you still have to do all that stuff. Even if you're on Raspberry Pi and you're using the GPIO module to light a light and turn it off, just like you do in Arduino with the setup and loop. You've got to, how am I doing? Pretty good. Okay. You have to turn the light on and off. And you might not always be able to figure out how Python is abstractly doing this. That's all I can say on that right now. Arduino programs, how many people have worked with Arduino? Oh, great. As you know, they have setup and loop. But did you know that setup and loop are part of a top-level Arduino object? It's very exciting. And I found this out because I did some digging because I found another IDE called Slober. I guess he's still out there. He's from the Netherlands, but the Arduino company doesn't want to hear about it. And believe me, I don't want to be off on a tangent again. But essentially, there's a class Arduino. And what is a class? And a class is a self-contained programming module that can do setup, and it can do loop, and there's other things it can do. And I found the object, and you can too, if you go to the right place. And that's the directory path where I found Arduino.h. That's the header file that describes Arduino. And in it, there's setup and loop. In addition to attach, interrupt, and shift out, these are all part of the object that is Arduino. Very exciting. Here's Arduino Blink. I'm going to show you why objects are important and you want to use them in your own programming. Even though you've always done setup and loop, and you're set up and loop to light a light. How many people have tried Blink? Well, if you've used Arduino, you've tried Blink. Here it is. In setup, it says pin mode. It should be, the built-in should be an output. And then it says, I want to write that high. I want to wait a second. I want to turn it low. I want to wait a second and loop, as you know, loops again. But these are the loop and setup are class functions in the top level Arduino object, which when compiled becomes the executable that runs. I said, that's great. I want an example for my lecture today. What should I do? I want to blink 3 LEDs. And I want them to blink at different rates. George, I'm going to pass you by. Okay. I'll send it around your way next time. So here's my project for today. Last year I worked so hard. You can pass it around the room when you're done. admiring the lights. And I worked so hard on FPGA last year, you have no idea. And then I came in here and flopped. I didn't sound like a guy who knew anything. It was incredible. But the group really liked it. But I couldn't do that this year. So I settled for 3 lights to blink. But look, if I do it this way, they'll all blink at the same rate. I want an LED object that will blink at different rates. So what do? I define the LED class, the .h. It knows what digital pin I want to blink on. It knows the blink rate. It knows blink on. It has a default constructor. You have to have that, of course. I may have had the copy constructor in there wrong. And you can set it up with all the variables in the constructor if you want. And then to continue, here's the CPP. Oh, here's how this stuff works. This is how it works. So I instantiate the LED. The LED, when it is instantiated, is told what pin to be on, what blink rate, and whether the blink should be blinking at this time or not. And then I add these files to the sketch. I rewrite the program. And guess what? In the setup, oh, I had to instantiate the objects, that 1, that 2, that 3. I initiate them in the setup. That I go to the init function of the class, and then I say, in the loop, all I do is pass them a heartbeat. Yes.
I'm confused about one part.
Yes.
You're using the Arduino's ID to wind up working with a sketch, but you're also using C++. How are you integrating those together? What tools are you using to bring C++ together with this?
Arduino IDE is a C++ compiler.
So it will take it native without making any changes?
Right. It's not C, it's C++. And setup and loop they're not like separate entry points. They're different functions in the top level Arduino ecosystem of the Arduino. Okay? So, does that answer your question?
I didn't realize that you could actually compile C++ code.
You can type C++ code into the Arduino IDE. It is a C++ compiler. Most of the time, we just turn on the lights and the pins that we want to turn on. And in this case, if I wanted 3 lights to blink, I would say turn them all on, wait a second, and turn them all off. But what if I wanted one to turn off every second, one every 5 seconds, one every 10 seconds? What would I do to change this? And that's why I've gone to object-oriented programming, because I don't want to count how many seconds go by. And if 5 seconds have gone by, turn off the second light. And if 10 seconds have gone, then I'm going to have a big if statement. It's going to be a mess. And we have to avoid a mess. We don't want spaghetti code, okay? Yes. So, okay. I'll be making spaghetti tonight. Can't get myself in trouble. Okay. So instead of that, what I've done here is because I don't want that situation where the code's not easy to read and it doesn't make sense to other programmers, I have defined a class LED. And remember, this isn't compiled yet, but when it is compiled, anything that is an LED will have these things in it. It will have private variables called digital pin, blink rate, and blink on. It'll have constructors. And I think I left out some functions because it's got to have some functions. I should have had a page in here with the functions. Oh, here's the final one. Here's the final LED.h header. This will be a separate, do you know how to add extra files to your sketch? Here's what you do. You say, you're going to type out all the stuff in LED.h, LED.c++, and you're going to add it to your sketch, and it's going to show up as other classes as other files, LED.c++ and LED.h. Okay, you've got my pen and my email, so I'll try to get the slides on my website so you can copy this for yourself. I think it's great. It took me a while to get the hang of C++. And then here's the final header for .h. It has a constructor. It actually has three constructors because there's different ways you can construct. When the main program's running, it has to construct LED 1, LED 2, and LED 3. George, let me get that. And then we're going to pass around the second example, and then we're just about out of here. So I can't believe how fast this has gone. If I look, here's the LED C++ functions. So in LED init, I'm doing the things I usually do to say that a pin must be set. But instead of saying digital pin mode output, I can't do that from another class. I have to mask the value and use some C type language to mask the value. Then toggle LED is something I have to check if the heartbeat's gone by. If the heartbeats come in for a number of counts, and if it has, I light the light otherwise, and I'm using a different methodology using C style language. Actually, C++ kind of took over C in this case. But remember, you can always go back to C and actually do it a different way. But this is very handy. There's no one right answer in programming unless you're working for, you're in a regulated environment. It has to be C++. If you want to use Forth again or Golang, and I'd like to learn Golang, you can do that. I want to use C++ in this case because I like having objects in my Arduino environment ready to roll. Then the whole thing, there's the whole project that I showed you. And then the final program, however, is right here. Oh, that's not it. Right there.
So your final program, why are you using the arrow operators instead of the dot?
Oh, arrow means dereference a pointer as an object. Dot means refer to one of the functions in this object. Do you know the difference between a pointer and a?
I know the pointer, but I thought most object-oriented programming, like when you're doing like serial, you're going to serial dot, so you're doing the method on the
because the best way I had to instantiate it as a global variable was LED star LED equals new LED. So what that does is it instantiates LED as 11, 12, and 13 with different blink rates, but then it puts it in a pointer because then I can pass the pointer around and I don't have to worry about passing a reference to the whole object. That was just my style in programming. When you do that, you point to, you're not using a dot. It would be equivalent to writing dereference the object, please. LED and then dot. Okay, so it's not dissimilar. And believe me, the disambiguation goes the distance with all this programming. So bear with me.
So Arduino's kind of a lot of flavors.
Yes.
This turns into an application. How much memory do you have?
I am facing that this works out. It doesn't take it all up, but let me show you the next example. And I'll pass this your way, George. I am facing a problem here. Is that I'm running out of space for all these objects. I tried to look up how much space all these objects take. This is the clock. The clock's not working because the real-time clock's not put on it right now. But in this case, I have a number of 7-segment displays, type displays on the LCD screen. Do you see them? I wanted to create a 7-segment object. Here's a graphic of the output I want to use. It's a frequency generator, and every time I need a numeral, it has to have a 7-segment display. So here's the .h with all the definitions, and there's the constructor, and there's draw digit. So I code once, run repeatedly, but it does have a bit of overhead. On the other hand, anything we do with Arduinos, so I have a solution for this that I'm working on, but it involves, the old MS-DOS didn't have a lot of memory either. And it had intermediate instructions, like interpreted instructions. So I am working on a solution where when I run out of 32K, I'll have some leeway. Yeah. Yeah.
You designed that board.
Yes.
Is something like that for sale? Do you have that available?
I have it for sale. It's on my website, and
This place, I don't
Oh,
know
it
if you
felt
know about that.
the batteries. Yeah, the batteries run out. Oh, thanks a lot. Yeah, yeah. This the batteries are out, but you can check out my board. I have it for sale on my website. I worked pretty hard to get them. And Jen will say, "Go ahead."
So speaking of battery run, yeah, Steve got a bunch of double A's, 6 volts. How much current draws is that apparatus?
It actually, this board draws about half an amp.
Ow!
Yeah, because it has two Arduinos and the display.
Oh,
So-
with the display, it's
It lasts about 2 hours on the batteries. Well,
with the display.
I'm waiting for one or people or companies to come along saying, "Hey, we like what you do, but do this instead." Okay.
E8 displays?
What?
You use E8 displays.
No, I haven't. I want to try them. However, I've used OLED. What I'm thinking of doing, instead of having 6 batteries, have 2 and an OLED display. Those are very nice displays and they're very efficient. Do you need C++ on Raspberry Pi? Raspberry Pi is Python ready. So really, to blink lights or even have the example we just had, you could do it all in Python very easily. So no, you don't need C++, but the kernel for Raspberry Pi, Raspbian, which is a Debian form of Linux, is built in C++. And I think we're out of time, right? But one important slide at all. If you don't need C++ on Raspberry Pi, why use it at all? We want very fast code that's native to the target machine, take advantage of C++ libraries, write our own Python libraries, and don't think you can't, okay? And port an existing code base. So these are the 4 reasons I could think of why you'd want to use C++ at all. And I wanted to have more examples, but we're out of time anyway. Okay?
Evan, may I ask, is there, one central place to kind of get like cheat sheets for Python and C++?
There's a lot on the web, George. You just have to keep looking. Yeah, there's a lot out there. So that's about it. I'm happy to answer questions.